This is the answer key for the Lewis structure and molecular geometry practice quiz. The first molecule we're going to look at is CO2. This is one we've done in class before. So we'll start with the Lewis structure. We'll take care of the NaSl. So for N, for need, we want to look at the fact that there are 3 total atoms. Right? There's 1 carbon and 2 oxygen, CO2. Each one of those atoms needs 8 electrons. Okay? The vast majority of atoms need 8 electrons. Exceptions are helium, hydrogen. Hydrogen is the one we use the most. Boron and beryllium. Otherwise, you can just assume 8 electrons needed, so 3 times 8 means we need 24. How many do we have available? If we look at carbon on the periodic table, it's in group 14, so it has 4 valence electrons. If we look at oxygen, it has 6, and there's 2 of them, so that's 6 plus 6 plus 4, which is 16 total available. So we know we need 24, but we only have 16 available. So in order to make this work, we subtract the 24 and the 16, and we get 8, a difference of 8, which means we're going to have to share 8 electrons. So now, if you have carbon, you can always put carbon in the middle, and we put 1 oxygen on either side. Sharing 8 electrons, remember it takes 2 electrons to make a bond. So if I have 8 electrons, I have to share, or have to make 4 bonds. So I always start with 1 between the center atom and each atom on the outside, because you have to have at least 1. The fact that there are 8 electrons being shared means I have to go back in and put a second bond on each side. So there's 2 bonds between each oxygen and the carbon. And then the last piece of this, for the Lewis structure, is how many are left. We started with 16 available. We shared 8. That means there are 8 electrons left over. You always want to look to the outside atoms first, see if they need any more electrons to be complete, and then if you use them all up and there's still leftover electrons that you haven't used, you can look to the center atom. The exception to this is, of course, never ever put leftover electrons on a hydrogen. Just can't do it. So in this case, if I look at the oxygens on either side, they're both the same. They both currently have 4 electrons each in these 2 bonds. Okay, so that means they only have 4 each, and they want 8. So I need to add 1, 2, 3, 4 more electrons on that side. 1, 2, 3, 4 more electrons on this side. There's my 8 shared electrons total, and each oxygen currently has 8 electrons around it. So if you think of this, here's all the electrons connected to oxygen. Here's all the electrons connected to this oxygen. And then if you look at the carbon, these electrons are all connected to carbon. So all 3 of the atoms in the structure now have 8 electrons connected to them, whether they're bonded or lone pair electrons, the leftover dots. So that's the first piece of this, is the Lewis structure. Now I'm going to just clean this up really quickly and then take a look at the shape and how we figure out the shape, and then the polarity. So we're just going to replace the bonds that we had. Redraw this really quickly. So we had oxygen here, 2 bonds, and 4 unbonded electrons on each of the oxygens. Okay, so there's your Lewis structure. Now moving over to the shape. Okay, we want to figure out what's the shape. When you're looking at the shape, you only want to look at the center atom, in this case the carbon, and you want to look at how many connections there are. The trick to this is these double bonds count as one connection because they're between the carbon and a single atom of oxygen on each side. So this counts as one bond region, or one electron region. This counts as one electron region. So the total is two regions. Okay, so when we go down to the shapes, we're looking at 2 electron pairs. Okay, that's the line of shapes possibilities that we're looking at. And since there's no lone pairs, there's only 2 bond pairs, then the only shape that we can pick here is linear with a bond angle of 180 degrees. So this is the shape that I'm going to draw when I get up to the next column here. I'm going to draw a circle in the middle with a line and a circle on either side. And we said that that is called linear. That's the name of the shape. And then finally, the polarity. Is this polar? Well, when you look at the shape, it's a straight line. It's not bent, it's not angled in any way, it's just a straight line. That's what linear means. So then the only question left to ask is the line the same on both ends? In this case it is. It's got an oxygen on both ends. Each oxygen has a double bond and 2 pairs of unbonded electrons. That all adds up to no polar molecule. Okay, if it's similar, symmetrical, has the same thing on each end of the molecule, whether that's the corners of a triangle, the corners of a pyramid, the ends of a line, then it's not going to be polar. All right, so the next molecule, the rest of these we'll get through a little more quickly as we go along. So the first thing is the Lewis structure. So we have nitrogen, and we have 3 chlorines. So hopefully you recognize that that was chlorine and not carbon and iodine, which would make a whole different molecule. So for the need, again, none of these atoms is an exception. They all need 8. So that comes out to 8 times 4, which is 32 needed. The available, okay, nitrogen is in group 15, so it has 5. And then the chlorine is in group 17, so each of those has 7. Add all that up, and we get 26. So we need 32. We have 26, which means we're going to need to share 6, and we're going to have 20 left over. Once you get the first 2 numbers, you subtract down to find the shared, and then you subtract again to find the leftovers. So let's draw this molecule. We're going to put the nitrogen in the middle, because we can't put 3 chlorines in the middle. And then we'll put a chlorine here, here, and here on 3 sides. Since we're sharing 6 electrons, if we make a bond, a single bond to each chlorine, that takes care of the shared electrons. I don't need any more, because I've already shared 6, and that was all I had to share in the first place. The key here is that we have 20 left over still. So let's put those on. And we'll start on the outside. This chlorine only had 2 electrons, so it needs 6 more. There's 6 dots. And that goes the same for this one. The bond is 2, it needs 6 more. And over here, the bond is 2, it needs 6 more. Okay, so that's 6 times 3, that's 18. We have 20. Look at that center atom. The nitrogen only has 1, 2, 3, 4, 5, 6. It's still missing 2 electrons. I've got 2 left, so that's where they're going to go, is right on there. Okay, so now the nitrogen has 8, each of the chlorines has 8, and I've used all my electrons. So now let's move on to what is the shape. Well, remember, for the shape, we're only looking at the center atom. So I'm only looking at the nitrogen for this. The nitrogen has 4 regions, 4 areas of electrons. Okay, so that tells us we're going to be in the row on the shape chart that says 4. One of those is a lone pair. So there's 3 bonds and 1 lone pair. So let's go take a look at the chart. Okay, here's the options for 4 electron pairs. The first one has 4 bonds. We didn't have 4 bonds. We had 3 bonds and one lone pair. So this is our shape. It's called trigonal pyramidal, and it has the three atoms on the bottom and the lone pair electrons on the top. So we're going to recreate that up here. We have the nitrogen atom in the middle, and you don't need to be specific about the atoms. We're just drawing a very rough sketch of the shape that we saw down below there. Okay, three atoms around the bottom, one electron pair on top. So the shape is a pyramid with a triangular base. Right, and the electrons are sitting up, the nitrogen is sitting on the peak of the pyramid, and then the electrons are up above it. That's the way the shape would look. So, that name, okay, we said that name is trigonal. So, with a triangular base, trigonal pyramidal. So it's a triangle pyramid, a pyramid with a triangle base. All right, polarity. Well, when you're considering polarity, the first thing I'd look at is the shape sketch. Is the shape sketch symmetrical? In this case, I would say definitely not. It's got three atoms on the bottom and a lone pair on the top. By itself, that would be yes, it's polar. I have to quickly note, if you looked up this shape online, it might have said that this is a non-polar molecule. And if you really want to get fine with this and nitpicky, it would be considered non-polar because of the distribution of partial charges. Okay? Because the chlorines are all slightly negative and the electrons up here are slightly negative. So it is, strictly speaking, it's not a polar molecule. But I told you that if it was asymmetrical, it's polar, and I will not give you an example on the quiz that is asymmetrical and nonpolar, like this one technically is. Okay, so if you said nonpolar, because you were following what I said, that it's asymmetrical, it's polar, it's polar. If you said polar, you're right, and I won't give you one where there's any question on the test. It'll be either polar or nonpolar by the shape. All right, CH3F, Lewis structure. In this case, we have a carbon, we have three hydrogens, and then we have a fluorine. So three different elements in this molecule. For need, the carbon needs 8. Hydrogen is an exception, it only needs 2 for each of them, and then the fluorine needs 8. So the total is 8 plus 8, which is 16, plus 2 plus 2 plus 2, so that's 22. The available carbon has 4 valence electrons. It's in group 14. Each hydrogen has 1. Hydrogen's in group 1. And then the fluorine has 7, rather. It's in group 17 like chlorine is. So if we add that up, that's 14 available electrons. Subtract 22 minus 14 is 8 shared, and there will be 6 left over. So if we start to look at the structure, carbon is in the middle, because we have a carbon, we put it in the middle. Fluorine, I'm going to put on the top, and then 3 hydrogens around the other sides. Which side you choose to put the fluorine on versus the hydrogens is not really important. It'll come out the same way every time. 8 shared electrons means 4 bonds. If I make 1 bond to each of the outside electrons, I make 4 bonds. Done sharing. Shared 8, had 8. The 6 left over is where the mistake might come in. Just remember, never ever, 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 ever put the dots on a hydrogen. And this fluorine, by the way, currently only has 2 electrons in that bond, so it needs all 6 of those anyway. Now it has 8 electrons around it. The carbon in the center has 8 electrons around it. Each of the hydrogens has a single bond, which is 2 electrons, and that's what it needed. So we're done with the structure. We need to look at the shape. Okay, so the center atom is carbon. Okay, carbon in this case has 4 bond pairs, or 4 electron pairs, I should say. Each of those electron pairs is a bond pair. So we're going to go down to the chart. We're going to look in the row for 4 here, And then the first shape is the one with 4 bond pairs. That's the tetrahedral shape. Okay, so we're going to draw this shape roughly up here. The shape sketch has the carbon in the middle. Okay, 3 atoms on the bottom, another atom on the top. The shape name is tetrahedral. That's an L. Okay, polar or not. Very, very often, tetrahedral is nonpolar because if you look at the shape sketch, it looks like it's got 4 corners of a pyramid that are all the same. However, in this case, we have one corner, in this case where I put it would be the top of the pyramid, that's different from all the other corners. It's a fluorine. Fluorine is super electronegative, which means it's going to pull all the electrons from all the other atoms to its end of the molecule, creating a partial negative charge. So even though the shape is a symmetrical pyramid, the fact that the pyramid has a top that's different from the base means that it is going to be polar. So this would probably be like the trickiest one I would give you on the quiz, where it's a shape that's normally nonpolar, but it is clearly different on one side, making it polar. Okay, C, Br4. So carbon and 4 bromines. Okay, for need, none of them is hydrogen, so it's 8, 8, 8, 8, 8. That's a total of 40 needed, 8 times 5. Available, we've got carbon with 4. We've got bromine is in group 17, so like fluorine and chlorine. Okay, it's got 7 apiece. 28 plus 4 is 32 available. We're going to share 8. We're going to have a whole bunch left over. We're going to have 24 leftover electrons. Building the structure, carbon goes in the middle because it always goes in the middle. Bromine, 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 bromine. Okay. Sharing 8 electrons. Start with the 1 bond on each side and stop with 1 bond on each side because there's 8 electrons. I'm done. The last piece is these 24 leftover electrons. Each bromine in this molecule currently has 1 bond, which is 2 electrons. Each bromine wants 8 electrons. So in order to make them all complete, I need to give each bromine atom in the molecule 6 unpaired electrons. And since I'm doing that for 4 bromines, 6 times 4 is 24, which means that's how many I used, and that's how many I had to use, so there we go. We're done. Okay, the shape. Looking at the carbon, just from the point of view of the carbon, this looks just like the last one. 4 bonds, no lone pairs on that center atom, which means we're talking about a tetrahedral shape. Okay, so we're going to draw that sketch again. Okay, we've got an atom in the middle, and then 4 atoms around it. The name of that shape is tetrahedral. And this one, okay, the shape sketch makes it look symmetrical, and this is one where all 4 sides are the same. So therefore, since they're all the same, it is non-polar. Okay, so let's move on. SCl2. We have sulfur and 2 chlorines. No exceptions here. They all need 8. No hydrogens to worry about. Available. Sulfur's in group 16. It has 6. Chlorine's in group 17. They have 7 apiece. So the need is 8 times 3, which is 24. The available is 7 plus 7 plus 6, which is 20. The shared is the difference between those two numbers. 24 minus 20 is 4. The leftover is 20 minus 4, which is 16. So this one's going to be a little bit different. So we're going to have sulfur in the middle, chlorines on either side. Share 4 electrons. One bond from the sulfur to each chlorine. There's 4 electrons shared. Done. 16 electrons being shared, left over means I can put 6 on each of these chlorines, because only one bond on each chlorine means only 2 electrons there. They need 6 more anyway. That only gets me to 12. I've still got 4 left. I'm going to put those 4 on the sulfur, and you probably drew it something like this, okay, with one on the top, one on the bottom, which makes it look like a straight line if you drew it straight across. However, when we look at the sulfur, it has a total of 4 groups of electrons. Okay, it's got 2 bonds and then 2 lone pairs, total of 4. Go down to the chart. 4 electrons total, electron pairs total. Not all bonds, there's not one. There are 2 bonds and 2 lone pairs. So the shape that we're looking at is called bent. Okay, it's like a water molecule. It has 2 atoms and then 2 lone pairs. So we draw the shape like that. Okay, we have the atom, we have it bonded to 2 atoms, and then we have 2 lone pair electrons, the way the shape is drawn. The name of that shape was bent. I can pretty much guarantee you every time you have a bent molecule, you have a polar molecule. Just because of the angle, there's usually unbonded electron pairs, which creates a discrepancy in the polarity. Next one is HCN. So here we have hydrogen. Remember, that's going to be one of our exceptions. We have carbon. We have nitrogen. Hydrogen needs 2 electrons. Carbon needs 8. Nitrogen needs 8. 8 plus 8 plus 2 is 18. Available, hydrogen has 1. Carbon has 4. Nitrogen has 5. It's in group 15. So if we add that together, we have 10 available. Subtract 18 minus 10 means we share 8. Available minus shared, 10 minus 8 means there's going to be 2 left over, so we're going to have 2 dots somewhere in this molecule. We've got carbon, put it in the middle. We've got nitrogen, we've got hydrogen. If you drew this up and down instead of side to side, so be it. Share 8 electrons. Start by making 1 bond on either side. Okay. Now I've only shared 4. I have to share 8. You always want to make the molecule symmetrical. Like in carbon dioxide, we put 2 bonds on each side to get 8. But you cannot double bond a hydrogen. Can't do it, just like you can't put dots on it. So my only option here is to add 2 more bonds between the carbon and the nitrogen. So that's a triple bond. All right, there's 6 electrons over here and 2 over here. There's my 8 total that I needed. Okay, so the shared is done. Now I need to figure out the leftovers. Always look at the outside first. Hydrogen's on one end, can't put dots there. Nitrogen's on the other end, and we said nitrogen currently has a triple bond. That's 6 electrons. Nitrogen needs 8. So it wants those 2 extra electrons that we have. And then carbon in the middle has 4 bonds total, 1 to hydrogen, 3 to nitrogen, so it's already got its 8 electrons. It's done with that. Now, what shape is this? Remember, we always look only at the center atom. And if you have multiple bonds on one side or the other, that only counts as 1 group of electrons. So this carbon has 1 group here and 1 big group, but it's still just 1 group on this side. So the total is 2 groups. Go down to the chart. The only choice we have with 2 electron pairs that are bonds is a linear shape. Okay, so it's linear. It is a straight line with 1 in the middle, 1 on either side. There's no angle, no bend. It's 180 degrees. The shape name is linear. Is it polar? Well, the shape might make you think no, because it's a straight line, but this molecule has hydrogen on one end and nitrogen on the other. So it's got 2 different ends, which makes it polar. Yes, it is. All right, CH2I2. we're going to have carbon, hydrogen, hydrogen, iodine, and iodine. So a C, two H's, and two I's. When we look at the need, carbon needs 8, hydrogen each need 2, iodine needs 8. So 3 times 8, right, 3 eighths, is 24, plus 2 twos, is 28 total. The available, carbon has 4, hydrogen has 1 apiece, iodine is in that halogen group with chlorine, fluorine, bromine that we've already seen, they have 7 apiece. So that's 7 plus 7 is 14, plus 1 is 16, plus that is 20. Okay, so I'll add all those up. That adds up to 20, this adds up to 28. Okay, to find S, we take N minus A, 28 minus 20 is 8. The leftovers is 20 minus 8, which is 12. So now let's draw this out. We have carbon in the middle. We have 2 hydrogens and 2 iodines. I always draw the similar atoms opposite each other rather than next to each other, just for the symmetry of it. We're sharing 8 electrons. If I make one bond to each of those outside atoms, that's 4 bonds, which is 8 electrons, done sharing. Now, there's 12 left. 12 dots. Look at the outside atoms. 2 of them are hydrogen, can't do anything with that. 2 of them are iodine, though. Each of those iodines currently only has 2 electrons in the bond. So each of them is going to need 6 more. And that gives me 12 shared. Done. What's the shape? Well, look at the center atom. It's got 4 bonds. So 4 groups of electrons, each to a different atom, so no double bonds or anything like that. So 4 electron pairs, all bonds, means tetrahedral. Okay, so that's a pretty common shape when you have carbon. Shape sketch, carbon, and then 4 atoms. Okay, so it's called tetrahedral. That was the sketch. The name is tetrahedral. The polarity, okay. Tetrahedral shape can certainly be nonpolar because of its shape. Is it symmetrical? Well, it doesn't have the same thing on all 4 sides, but it's got 2 pairs of things that are identical. So whatever the charges might be, they're going to be evenly distributed. Even if their hydrogen and iodine are slightly different, there's going to be 2 of each. So it's not going to create polarity. So it's similar or symmetrical enough that we're going to say not polar. Last one, H2S. So we've got hydrogen twice, and we've got sulfur. Needs. Hydrogen needs 2, sulfur needs 8. Available. Hydrogen has 1, sulfur is in group 16, it has 6. So total need would be 12, total available would be 8. Need 12, I've got 8. 12 minus 8 means I'm going to have to share 4, and 8 minus 4 means I'm going to have 4 left over. Sulfur, hydrogen, hydrogen, share 4 electrons. Well, I got to make 1 bond on either side. That takes care of those 4 shared electrons. Done. 4 left over. Where are going to put the dots? Well, you're not going to put them on the hydrogen on either side because they're both hydrogen. So the only place left is the sulfur. Okay, now let's look at the shape. Sulfur has a total of 4 groups, 4 sides of electrons. 2 of them are bonds, 2 of them are lone pairs. So 4, nope, not 4 bonds, not 3 bonds, but 2 bonds and 2 lone pairs. That's back to our shape bent. So we would draw that like this. Those are supposed to be 2 dots and 2 dots. Okay, the shape name is bent. And again, bent is pretty much always polar. You can pretty much count on that. Okay, this molecule, in fact, if you substituted the sulfur with an oxygen, would be water. And sulfur and oxygen are in the same group, so they have very similar properties. So this molecule is the same shape as water, and it is polar. So there you go. So you will get the shape chart, right, like this. You will get a periodic table, and you'll have 8 molecules to work on for the quiz, and that's it.